April the 20th, 2025. Guys, hope everyone's having a great and safe travel time during this Passover weekend. Just make sure that you pay attention to everything on the highways. Things can get crazy very quick sometimes, especially when you're passing through some of the big cities. Always watch that. Guys, what you're looking at now is called the geoelectric field models. We have the U.S. We also have a Canadian version. We'll look at both. And I'm going to play this thing forward. What it is going to show is the electrical field that moves through our ground, through the rocks and soil and things like that, from solar energy. When it hits our magnetic field, it's transferred down into our planet. And then when you have openings in the shield, you really have a lot of transference to the ground. And we all felt that, guys, back, what was it, on the 16th now, as we look at it. But let me play this forward. I want to show you something. And you can see this is coming up to the last measurement today. I think we have 16 stations that report that here in the U.S. Again, Canada's involved also. But what you're seeing is the energy levels change as it goes through the day. The scale here is in blue is weak. You get up into the yellows, orange and reds, purples, and to white, you're really strong magnetic fields. Now, something to pay attention to here is, of course, stands out like a sore thumb is the Appalachian chain. You got a lot of rocks, a lot of minerals there, and you're going to see greater conductivity, right? And that's what is being picked up, energy levels of the sun hitting the surface of our planet. Now, you can also see a kind of a shadow through this, and pay attention to that. It's important. It comes down and goes back up through here, but it's much less activity on the west coast. Why would you think that? Well, if you understand what Lemuria was, or the North American Craton, this was very shallow seas for a long time, millions of years right here. And then you had the North American Craton right through here, and it's one big unit, okay? And so it's a big rock, goes up into Canada, comes down through the U.S. The southern tip here is where we have the New Madrid Fault Zone. But you can see the energy today moving through this area. Now let's take a look at Canada. Now it's almost the opposite. When we include Canada, it's not just Canada, it's both. But the wider areas are here. See, right in this area, that's the most conductivity in the whatever's in the soil, whether it's rock, a mixture, whatever it is, this is where it's most intense, and this is where we see the most intense auroras, right? Going back to the 16th, though, it was a pretty different story, but again, you can see this form of the North American Craton right there. And this is what I'm talking about. Very simple, basic math. Some people call it Laurentia, but it's the North American Craton. The larger sections of it are in Canada, and it goes all the way under the oceans into Greenland. Check this out. And it says the continental crust that has remained relatively stable for the past 600 million years. All of this deformed Craton area and through here, guys, was shallow seas. Now, since that's receded, what happens when you have salt water over land for a very long time? You get a desert, right? And you can see that out into this area, into the Gulf of America, into the Atlantic, very different story. Different soil makeup completely. A lot of this deformed Craton area could be where the mountains eroded over 600 million years worth of that, mixing with this belt here, guys, that they say, again, was very shallow seas. And just quickly, so as a good reference, let's go back to today's map. You can see the highlighted areas here. You've got, we play it through. Now let's go back to the first model just as a reference point. Again, you can see your greater energy in the yellows here, not that intense compared to what we saw on the 16th. Now let's take a look at that. Now this is going back to the 16th, a few days ago, and this was 10 minutes of that G4 magnetic storm. Look at it. Totally different map. Look at the intensity along the Appalachian chain here, and you can see very clearly the rock surfaces, or the rock structure of the ground all through Canada and along the North American Craton. When it gets very quiet there, The shadow comes out in it. You can see where your non-rock structures are, most of them here. Of course, you've got some mountains and all in that area, but the big ones, the craton structure, 600 million years old, is very conductive. Look at this. So again, we didn't even see any reds or oranges today, just a little bit of highlighted yellow through the Appalachians and a little bit up into Canada in this area. What they're saying is space weather doesn't only happen in the sky, it's in the ground too. On April the 16th, a severe geomagnetic storm that you're seeing here moved through the soil and rocks in North America. The voltages were the greatest where you see the red, and they were measuring them. As a matter of fact, guys, they were 70 times more powerful through the Appalachian chain on the 16th than they are normally, including today. Not twice, 70 times the difference. And so you think about, you're dealing with geomagnetic storm that's pounding you with radiation from a vast opening in our magnetopoles, and then the ground's picking this up. And so people talk about grounding a lot, and I love walking on a wet beach because of that. But guys, when you've got this much charge in the ground, you're almost in a trap. You're being bombarded from above and below. And maybe that intensifies a lot of things through our body, because we are an electric universe, and we are electric, carbon-based, but electric. You have electric signals that depend on a lot of it depends on keeping enough moisture in you, that transfers signals from your brain, electrical pulses, through the rest of your body. So we're all affected by that. People were talking about severe back pains, unusually severe, in places they didn't really have them. Same thing happened to me on the 16th for that day. And getting more and more information of other people, not just in the comments, but had severe effects that day, crippling effects like they've never had before. But this was the difference, and this is the danger of another danger of the geomagnetic storms getting this intense. Now, when ground currents run through this area, what happens? Ground warms up, lava warms up, and the earth swells in a way. Anything heated expands, but when you have lava movement under it, you have earthquakes and volcanoes, right? And so that's one of the things that, again, another effect of this ground current. Right now, the sun is not that active, but we had a powerful flare yesterday. It was just under next flare. It was on the left limb, so it was not directly earth-facing, guys, but it produced a solar flare and a proton burst that were highly unusual. Let's take a look at that. Excuse me, guys, it's still early, foggy, but this was the day before yesterday, okay, on Friday, M44 solar flare on the southeast limb. Look at that beautiful image guys, it was the next flare, but because it was not directly facing the Earth and the satellites between us and the sun, it didn't quite reach the X category. But you can see the signature, and it's quite clear. And today and tomorrow, guys, we're going to start feeling the solar stream from this extremely large coronal opening, guys. Again, it's an opening in the magnetic canopy over the sun. In other words, I say it a lot, you see these big lines over here that coil back and forth, these big magnetic loops. Energy leaving the sun will be trapped in these loops, transferred back down, and that may be one way that it stays self-sufficient, feeds itself, or back feeds. But these areas, there's nothing to trap that outgoing solar wind, and it just blasts straight out in continuous forms. The little white lines, guys, are indicating filaments that can release in a whip-like motion and cause a CME. But right here's where that solar flare came from, right there. Again, it was an X flare, but wasn't rated that. If it had been just a little further over to the right, our satellites would have picked up more of that energy that was basically blown out to the left of this image. But again, something happened to the plasma, almost like suddenly there was a tremendous separate gravity field around the sun. Let's take a closer look at that flare. Bottom left corner, timestamp 17th going into the 18th, guys. Watch this area right there. Now, that's your coronal opening, the darker section that has no magnetic canopy at all. Watch this flare right there. Normally, when you see something like that happen, it will follow the direction of that stream. But guys, this thing came out and dropped straight south, if you want to look at a north and south orientation. And it's very unusual. I don't know what happened there. But again, I was not the only one to catch it. Most of you guys are probably realizing that looks a little odd. Again, if they come out from that area, they're usually going to head towards where I had that red dot. Now look at the second image as it continues to fall. I guess it's just a big blob of plasma, guys. Now this is the flare itself. Notice it's just below a next flare, which is the next line up. They're calling it a 4.47. And again, it's directional the way they measure this. We would have had a next flare, but it's coming from the group of sunspots that I was warning about, showing you had sunspots coming over with blue and red coloring, indicating possibility of very strong flares there. This is what it looked like on a different satellite when that plasma dropped south of the sun. Check that tail out, guys. Very large amount of energy pushes out. Here's another image. They're saying this mass of hot plasma 10 times wider than Earth just dropped off the edge of the sun. NOAA's Solar Ultraviolet Imager on the GOES-19 recorded the event just after 2330 hours, or 2330 on April 18th. That's UTC time. This is the result of an M4.4 class solar flare behind the sun's eastern limb. Something about the magnetic topology of the unseen blast site squirted the debris straight down, an unusual direction for solar explosions. They're saying it will not hit the Earth. It will not directly, but anytime you see a flare like that, within 8.2 minutes, the light energy is already hitting the planet. If you can see it, it's hitting you. If you see a light bulb turned on, you're going to have some light hit you if it's visible. And so that's what's going on. But this is just the plasma. That's not that huge tail that we just saw on LASCO C3 in the blue images. Things are changing on the sun, guys. Science is changing. We're paying attention to it. We're trying to learn everything we can. We're watching it. You watch it again. Have a great weekend. It's a heads up. Be safe.